Okay, everyone, so let's get started. I'm going to share my screen real quick. And before we start, I would like to tell you that I can't read the chat during the talk. So if you have any questions, I'll make sure to check back after the complete webinar is done. So make sure to add in your questions in the chat whenever you get them. All right, cool. So I'm going to share my screen, and here we go. All right. So hello again, everyone, and welcome to the fourth webinar by Deepstream. I'm Srushtika Neelakantam. I'm the Developer Evangelist for Deepstream Hub, and today we'll learn more about the HTTP API by Deepstream, why it was released, and how you can use it within your applications. So first of all, HTTP in real time. What really? I mean, why all that Deepstream has ever spoken about is real-time technology and real-time web. But from what we already know about HTTP, it's far from the protocol you would like to use to build your real-time applications, right? So why did Deepstream decide to release a HTTP API? Let's get to the reasons right now. And there are a couple of reasons. Let's understand them one by one. Starting with IoT, of course. In IoT, you have these sensors which are very low power devices, and building something like implementing a protocol like WebSockets is really complex and causes a lot of overhead on these devices. These are very low powered and it consumes a lot of battery. Also, fun fact, not all use cases in IoT require you to have a persistent connection like in WebSockets, right? I mean, consider an example where you have sensors which are monitoring temperature in your home. Now, the temperature is something that doesn't really change rapidly, right? So you can actually ask the sensors for temperature readings every hour or so. And this asking every hour doesn't really require you to have the connection open for the whole time. You can just simply make a HTTP request to the sensor every time, like every hour, when you would like to know the new temperature, if it has changed, etc. So that's one reason HTTP API was released. Next, bulk dump. What I mean by this is, the deep stream is not completely, I mean, even though we talk about real time data and just the most recent data, you always have this database as well in the backend, right? You store the data that you've been using and retrieve it whenever you require it later on. But think of a scenario when you have so much like a load of data which you'd basically just want to dump in the database. For this, you don't essentially would like to set up a WebSockets connection and think about all the overhead that it comes with. You can just simply make a HTTP request with all the data that you would like to do. One go, you just tell the server, here's the data that I would like to have in my database, and it just does the work for you and returns a success as a response or unsuccessful response depending on your request if it was correctly or poorly formed, which makes sense. Next, no deep stream, no problem. Now, what I mean by this is, you might have sometimes your own server or some other application which would like to communicate to your deep stream application in some way or the other for some various variety of use cases. In such a scenario, you don't want to implement the whole connect to deep stream bit in your website or your application again, right? So you can just simply make a HTTP request. If it is a one-off request, you can just make a HTTP request to the HTTP endpoint provided by Deepstream, and you don't even need to connect your client. Have the SDK given by Deepstream, download it, and do anything of that sort. You can just directly make a request to the HTTP endpoint, and you get the response back. Of course, if there is some authentication involved, you need to make sure the authentication is successful as well. We'll see all that further on through this webinar. Next, if you're a fan of using CGI languages like Perl, PHP, etc., we of course got you covered. HTTP is what you love to use, and now you can use DeepStream. If that was something that was stopping you from using DeepStream, you can of course use the HTTP API of DeepStream with those languages right now. So now that we understand why HTTP API was released by Deepstream, let us understand what actually goes behind it and what are the different elements which are part of this HTTP communication protocol that might be useful for us. So of course, you're not here for a talk which explains you how HTTP works. I mean, all of us know it already. But for the sake of completeness, let me just quickly run over this. You have a client, you have a server, you simply make a request to the server, a HTTP request, of course, and the server will return back the response, be it some data you've requested for or some service, or if your request was badly formed, of course, the response will be unsuccessful. But there will be definitely a response, right? There will be an error as a response. That's basically HTTP. Now, if you want to come somewhere close to the real-time functionality, like asking the temperature sensor every hour for new temperature, etc., you could do essentially three things with HTTP. These are AJAX polling, long polling, and use the features with HTTP version 2. With AJAX polling, it's the best scenario you would use for the temperature sensors example, where at every interval, you just repeat the request and the response cycle. You just repeatedly ask the server again and again if there is any new data which was created that the client might be interested to know. So what happens in these request responses is there are chances that the server doesn't actually have any new data simply because it wasn't created, and it just returns a response back saying no new data. But this is a lot of overhead, right? I mean, even for having a response saying new data, no data, you're just continuously sending requests and responses to and fro. This is somewhat a better scenario when you have long polling, in which case it still is a request and response cycle, but you have an option to persist the connection. What I mean by this is after you send a request to the server for some data or service, you actually are allowed to keep that connection open for a little longer and hope that the server by the time this time difference is elapsed, the server might have some new data that it would like to give you back. So it's just probably like covering two request response cycles into one by persisting the connection or keeping it open, basically. And again, there are chances because this persistent connection, there is a time limit until which you can keep this connection open. After that, even then, if the server doesn't have any new data, it just returns a response back saying, I'm sorry, there was no new data created and I can't really give you anything. And after it returns a response back, you again continue doing this request and response cycle again, like you would usually do in a AJAX polling, again with persistent flag. With HTTP version 2, though, it's not just persistence, it also allows you to batch requests and responses. What this means is, this is very interesting because we'll see a use case of this further on in the webinar. So what happens here is you have multiple requests for the server. So what you can do is instead of generating a new request and response cycle for each of these requests, you can actually group these requests and send them in one go to the server, and server will of course service them or process them all of these requests individually. And again, all these responses will be grouped and sent back to the client as a single one, which is really interesting. Why? We'll come to know further on. So let's actually see. Let's face it. HTTP isn't a real-time protocol like WebSocket says. You don't really have the connection open, and it is a purely pull-based paradigm where the client has to ask the server for some data or service, and the server can't really push any data whenever some new data is created or it has access to some new data, right? And because of this reason, a lot of features in Deepstream that you've been using might not be supported with the HTTP API for obvious reasons by now. For instance, you can't really have a publish subscribe messaging pattern. You can, of course, publish events like you send a HTTP request where you're emitting an event. That is possible, but you can't really subscribe to some events because when you publish an event, you tell the server that this is what I'm going to do and that's it. It's like a one-off situation. But when you're subscribing, you're expecting the server to send you back something when something else happened. But for that, you need to have a connection open with the server, which is not the case with HTTP API. So it's pretty straightforward that we can't really have subscriptions with HTTP API. And then, of course, you can't really have data sync. You can't be notified every time a record changes, or you can't have synchronized state of the application across all your clients with the HTTP API. Because of the same reason, again, the connection is not persistent or it's not open. So if you want any data, you just ask the server and it gives you back the then current data it has. And you can, of course, do presence. You can ask the server, hey server, who's online at this particular time in my application? And it'll give you all the usernames of the people who are online. But you can't really subscribe to it again for the exact same reasons that we spoke about earlier. You can't get notified whenever a user logs in or whenever a user logs out. That was otherwise possible with the WebSockets server. And anything else that you can imagine within HTTP that would require a persistent connection, that is not possible with HTTP API. And it makes total sense by now, right? So now a general format for any, okay, this slide is a bit messed up right here. So a general format for any HTTP post request, not just with Deepstream, would be you will post some particular data to a HTTP endpoint URL, which is given to you by whatever service you're using. So with Deepstream, as with all of our webinars, even in this webinar, we'll speak in general about both Deepstream IO and Deepstream Hub. So we'll see how will you get this HTTP endpoint URL in both of these scenarios. First of all, with Deepstream IO, you of course have the config.yaml file, which comes when you along with the server when you download it. And in the config.yaml file, you have a section called HTTP, which is completely the configuration with respect to the HTTP server that is part of Deepstream. I mean, we all know that Deepstream comes with both the HTTP server and the WebSocket server, right? So here's where we configure the different options we would like to use with the HTTP API. Let's quickly run through the options specified here. So the default port on which the HTTP API of Deepstream communicates is 8080, and the host is localhost or 0000. And allow auth data is pretty interesting because if you say it's true, then only then it would allow post requests to be sent to the auth endpoint. So there are two endpoints within Deepstream basically. One is the auth endpoint where you will send the authentication data and you will get a response back as a token or some other client data. And there is the general HTTP endpoint URL to which you will post all the other subsequent requests like emitting an event or reading a record, etc. We'll see examples of all these further on. But this authentication is only possible if you allow this auth data and set this flag to true. One thing to note here is that with deepstream.io, you don't really have a setup where you will be returned back the tokens. So you'll have to set up your own custom authentication handler if you're expecting some tokens like a webhook authentication, having your own HTTP server, etc., which will give back to you the token, which you can then use with your subsequent requests. Because as we know, HTTP is stateless, right? So you can't, like we earlier did with WebSockets, you can't really authenticate yourself once and then you can just keep on sending subsequent requests, assuming that the server knows that you are a authenticated user now. Because once you're done with the authentication, the server essentially forgot who you were. It's stateless. So you have to tell it again and again who you are in order to keep the connection possible. And then you enable the auth endpoint. If you enable the auth endpoint, you will basically be able to make authentication requests to the auth path. By default, the auth path is /auth, and the post path and the get paths are /. You can, of course, change this if you are using some kind of a custom authentication handler. And if you wish to check if Deepstream is alive, you can simply make a post request, simply make a get request to /health check, and it should essentially return a 200, which would mean that it is indeed alive. And by default, Deepstream accepts all origins, but if in this particular flag allow all origins, if you make this as false, only when you specify one of the origins which are specified in this particular list below this, if you specify one of these origins in your HTTP header, only then that will be accepted, that HTTP request will be accepted and further processed by the Deepstream server, otherwise there will be an error thrown. So we now know how the config.yaml files, but what happens in Deepstream Hub? Now things are generally easy when you come to Deepstream Hub, right? So there's a pretty looking application dashboard. So when you go to the admin tab on your application, you have all these URL endpoints already there. So you have the HTTP auth URL, which you're interested in order to perform authentication. And then you have the HTTP URL for performing the subsequent request after the authentication has been successful. Now, I'm not saying that authentication is necessary. We also have the no auth, as you already know. So you can completely skip the authentication step completely. So you never use HTTP auth URL as well. It's not really necessary, as we'll see further on. Let's start off with the authentication request and what it would look like. So in the payload, you would say, if at all you would like to have some kind of an authentication and it's not really no auth, then you would have an authentication request, the auth endpoint that we spoke about earlier, and you would specify the type as webhook or any other authentication. Now, if you remember, we have different authentication methods available with Deepstream IO and Deepstream Hub. We'll have a quick look at it after this slide as well. So for instance, you're using a webhook auth, you would say type webhook, and whatever the parameters your HTTP authentication server is expecting, here we'll assume that it is expecting an email and a password. We give it those, and the authentication should be successful if the parameters are true. So if you remember, with Deepstream, you have no authentication, file authentication, and webhook authentications as the different types of authentication possible. And with Deepstream Hub, you have no authentication, token auth, email authentication, as well as webhook auth that you can use as different types of authentication mechanisms, right? Now, coming back to the authentication request, for this kind of a request, an example response would essentially look something like this. If the authentication was successful, it would say success as true, and it will give back to you the token, which you can use for all the subsequent requests. Now, this is basically, it's optional. You can still send all the auth parameters that you initially sent with every subsequent request as well, but just using a simple token eases our work. And then, of course, we have the client data, which is returned back to the client whenever the authentication or the login is successful, as we know it. Next, assuming that we crossed the authentication step and we didn't really try to implement no authentication, let's see how the further request would look like and what are the different kinds of post requests that we can do with the HTTP API or Deepstream. Before that, if your authentication had an error, if it was not successful, the error messages are returned back as plain text messages, and they usually have the status code starting with 4 and they're in terms of 400s. So you'll know there's some kind of authentication error, and you'll know what kind of an error it is because it's just plain text and you can just read it. So as I said, the different types of post requests that you can do with Deepstream's HTTP API are emit an event. Remember, you can't subscribe to an event, you can just emit it. You can read a record, create or update a record, delete a record, make an RPC, not really subscribe to an RPC or request an RPC, and you can just query presence and not really subscribe to presence, which are pretty straightforward, right? Let's quickly run through how each of the payloads for these things look like and how, in general, a post request is structured as a command in Deepstream's HTTP API. So for the command format, the requests have two necessary or essential parameters, which are topic and action. So these are must to be included in your request. Topic will be something like what feature you're trying to do a request on. For instance, it can be an event, it can be a record, and things like that. And action is what action you're trying to perform on that particular topic. For instance, it can be emit for an event, it can be read for a record, and so on and so forth. And for the responses, there are 4 essential responses that we get back: the success flag, error topic, and error event. Now, apart from this, depending on various topics, we also have some other kinds of responses that we might expect in some cases. We'll see them, we'll have a look at them as we move along with different topics and actions they are able to perform. So starting with emitting an event, it's pretty straightforward. The topic is event, action is emit, event name is the name of the event you're emitting to, and the data is again in JSON format, the data you're sending is when you're emitting that event. So actually, before moving forward and looking at how all of the other things are done, let's quickly look at how it would actually look in a complete file, which is speaking to a HTTP endpoint on deepstream. Let's quickly have a look at an example, all right? So I'm here in some particular, JavaScript file, and let me quickly increase the font size for you. Okay. So here I have the request body where, as I showed you, we have the topic as event, we have the action as emit, event name as the name of the event we are trying to emit, and the data, which is just date.now as a dummy data that I'm using here. And the URL, here I'm using the Deepstream's open source version, the Deepstream IO. So my URL would be localhost 8080 because 8080, as I said, is the default HTTP port that Deepstream works on. And I'm just making an Ajax post request where the method is post, of course. Header, I would say application slash JSON because we have the JSON for the body in the JSON format. And we would specify the URL as this URL and send the request body as part of the data, which is this body, right? And after it's done, as part of the response, we'll just log the response, and it'll have the response that we just saw, which would be a success along with any data that would be returned. In case of emitting an event, we'll basically not be getting any data back. It's just if it was a success or a failure. We'll actually run such a file and see, but we'll do that further on when we look at how all of the different post requests are done in Deepstream, like with different topics as well. So getting back to the presentation. So that's how emitting an event was done. And for reading a record, again, it is pretty straightforward. You have the topic as record, action would be read, and of course, the name of the record which you're trying to read, right? And with all of these, you have to remember there is some kind of permissions involved with all the records, and it will be successful only if you have permissions to read that particular record. Otherwise, the response will be just an error with which will specify why your record read was rejected. It's all plain text, so it's really easy to debug as well. Again, for reading a record, the response will look something like this. If it was successful, it will say success as true and version as 2. Now, this is something new. Of course, we get the data, which is part of the record, because we're trying to read a record, and that's what we're mostly expecting. But why do we even get the version number? Now, if you know, all of the records in Deepstream are versioned using version numbers. So every new update that happens to these records has a version, needs to have a version, one more than the current version. Otherwise, it throws an error saying the version already exists. It's a version conflict, basically. So why do you need a version number is because with the HTTP API, you need to take care of the versioning yourself. Deepstream doesn't do it for you. So what happens is if you're trying to create or update a record, you specify a particular version number, which needs to be one more than the previous version. And how will you know the previous version? One way is when you read a record, the version number is returned. So next, if I want to just update this record, I would specify the version as 3, which is one more than 2. Of course, even if you specify a number which is not one more, but a lot more than 2, like say 5, it'll again throw a version conflict. So that's what we need versions for. And if you would not like to read a record and instead just have a version number just for the sake of updating it, you can do something called record heads, in which for the payload, you'll have the topic as record, action as head, and you will just specify the name of the record. And in the response, you will get the success flag, of course, if this request was successful or not. And one important thing is you'll get the version number of this particular record back. So you're essentially not reading the whole record. So you're not getting the whole data, which is part of the record. You're just getting the version number so that you can update it further on. It'll look something like this. So you have the success as true and the version of the particular record is returned back to you. And where would you use it? As I said, you would use it for creating or updating a record. And this is how you would do it. The action would be write, name of the record. Path would be if there is only a particular path within that record you're trying to update, which is optional. You can update the complete record as well. And you would specify the version number as well, which obviously, as I said, needs to be one more than the version number that currently exists. And of course, you'll send the data that you would like to update the record with. Now, one thing to note here is you can always specify a version number of -1, which basically means that you don't really want to care about the version conflicts. You just want to write a hard override to the record without having to care about if there is going to be a version conflicts or things like that. So -1 is like a forced write for the records, which always comes handy in certain situations, and you know what kind of situations I'm talking about. Moving forward, so the creating and updating a record, if the creation was unsuccessful or the updation was unsuccessful due to a version error, we get a response which looks something like this. So success will be false, and the error would be the error, which is record update failed because version 6 exists for the particular record, and it'll give us the error topic, event, current version along with the current data. Now, why this current data is helpful? Because you now have two different sets of data, one that you were trying to update the record with, and the one that already exists in the record. So this gives you a clear idea of figuring out and coming to a decision of which data out of these two different sets of data do you want to actually have within the record. And you can just make a call and update the record with the correct version number next, right? And then deleting a record is again straightforward. If you have the correct permissions and you specify the topic as record, action as delete, and the record name as the name of the record, you just essentially delete the record and you get the response back. Now, to make an RPC, you can't actually request an RPC, but you can obviously make an RPC and expect some of the clients to be subscribed to this RPC, because those clients can still be functioning on WebSockets, on the WebSockets server within deepstream, but you're just making that RPC, making the remote procedure call via a HTTP API, which is totally possible. So we'll see such an example. And the topic would be RPC, action would be make, of course, name of the RPC that you would like to make, and the data that you would like to send to the particular remote procedure call, which will then process it. And the response will be something like, if it was successful, it'll be a true, and the data after the particular client or the provider which is providing you the RPC has processed it, the data whichever it is responding back with, that will be part of the data flag within the response. And then, of course, querying presence is one of the straightforward things. You have a topic as presence and action as query, and you get a list of all the users. You get a list of their usernames essentially who are at that point of time online in your deepstream application. Okay, which will look something like this. So it's basically an array of all the usernames of the users who are online in your application at that particular time. It's not a changing data. You're not subscribed to it. One thing which is interesting, as I said, which was possible with HTTP version 2 was batching HTTP requests. And it's actually possible to do such a thing with Deepstream's HTTP API as well. Let's quickly look at an example of how you would do it. Now, here I have a client application, and on my terminal, I would run a Node.js application. First, let us quickly go through the code of what it's trying to do. The index page is basically having a Deepstream JavaScript client, and I have a client.js file where I have connected to my Deepstream application, which is running on WebSockets and hosted on Deepstream Hub. And I'm logging in via email auth. So assume that I have a user with these credentials within my application, and assume that these login credentials are true because they are. And in the callback, I have the success and the data, and if it was successfully logged in, I'm just starting the application where the only thing I'm doing is subscribing to an event, which is called my event, and consoling the data whenever that event is published or emitted, right? So this is just a client which is subscribing to a data which is still running on WebSockets. We're not even connected to the HTTP API. And we have a record, we get the record users/DS webinar, and we are subscribing to the first name path within this record, and whenever the data is changed, which is logging in this particular data. That's what our client is doing. Now let us see what the Node.js file looks like. Here we are requiring the client, Deepstream's client.js, of course. the JavaScript client, and I'm using a third-party library called request to make HTTP requests simple. And I have the credentials where I have the two different URLs, the auth URL that I spoke about, which basically just has the auth path, and the normal URL, which we would like to use with all the subsequent requests after our authentication is successful and we return back a token, right? Now, I'm just calling this function called authenticate, and I'm sending these credentials. So what I'm doing here is I have an auth body where I have the type as email auth, the email, which is test@gmail.com, and password, which let's assume we have such a user with a very dumb looking email ID and password. Okay, and then I'm basically sending a HTTP request where my URL is credentials.auth URL, because here we are authenticating the user, so we need to use the auth URL and not the regular URL. And the method is post, of course, and it is a JSON body, and the body would be auth body. This is the payload we are sending in the HTTP request, and when the response is given back, we're just initializing with the token which we receive, assuming that the auth was successful and we indeed receive a token. So once we receive a token, here is something interesting. You can actually batch your different kinds of requests together with Deepstream. What happens here is, of course, I have a token which I'm sending with every HTTP request, as I mentioned earlier, because HTTP is stateless and you can't really expect your authentication to be remembered by Deepstream server. So you have to, every time you make a new request, you have to keep telling it that, you know what, this is me, this is my name, this is my email ID, this is my password. Or you can use a token using which Deepstream alternatively identifies you without you having to specify your email ID and password all the time. So that's what we're doing here. Within the request body, we have a token for authentication, and within the body, we actually have 3 different requests, as you see here, which are batched together. There is an event which is being emitted, there is a record which is being written, and there is also a presence query which is being performed. And at the end of all of it, you again make a HTTP request with now the general URL, not the auth URL. The method being post again, JSON true, and for body you're sending this particular request body containing 3 different requests. And after it's done, I'm just logging the response that is being returned. Now, one thing to note here is with respect to the message counts that you see on your Deepstream Hub console or the dashboard, if you're sending multiple requests as a single batch request in HTTP, you can't really fool around. These will still be considered as 3 different messages sent to the Deepstream server. So it'll essentially be counted as the number of single, individual requests that are sent to Deepstream. So messages are counted that way. But in a sense, it's a lot faster because you don't have to set up the connection, authentication, validation, and all those steps that are involved in setting up a new request and response cycle every time in HTTP. So that's essentially minimized. So let's actually run this application real quick and see if this works. So I have a client here, and here I would be running my Node application. Let me quickly maximize it. I don't know what just happened. Okay. So because we have a presence query as well, let me open up a new user as well. So we essentially have 2 users right now, and we have the console open, which is client logged in true. Now here, let us quickly run the main.js file and see what happens. If you remember, main.js file has 3 different HTTP requests after the authentication is successful. So it has the auth request to the HTTP auth endpoint, and then it has these 3 different requests emitting an event to which this client is subscribed. So we should essentially get a log on our console whenever this particular request is done, and then we are reading to a record and to which again this client is subscribed to, and we are doing presence, which we are logging right here in the console, in our local console. So let's see if that works. I run it and it says, so we have 3 different responses here, right? If you see, So we have the success true for the first one, which was emitting an event, and we got the event data here because this particular client was subscribed to it. And we have the success is true as a second response, where we had written to a record and we specified the first name as Srushtika. That's what had changed. That record wasn't really it didn't exist earlier. I just created it and updated it. And since this particular client on my left side is had subscribed to it, it showed up the data on the console. And the third one says success true, and it also returned me the name of the users, like the usernames of all the people who are online currently, which makes total sense. So that's all about DeepStream's HTTP API. It's pretty straightforward to use, and you now also know the different use cases that you can use it for. So go ahead and start using it. Good luck. Thank you very much. If you have any questions, I'll quickly check the chat channel on Zoom, or you can also tweet me your questions at Srushtika, or you can send your questions in later again at info@deepstreamhub.com or srushtika.neelakantam@deepstreamhub.com. This webinar is being recorded and will definitely be made available on DeepStream's YouTube channel. So you can come back later and check it out how many ever times you want. So going back to Zoom, and I've stopped sharing my screen. Okay, do we have any questions real quick? Okay, no questions from Adam. Does anyone else have any questions? Of course, it is pretty straightforward. Yes, a question? Okay, Sla seems to have a question. I'm sorry if I pronounced your name wrong. Of course, you're welcome for the presentation. Why don't DeepStream fall back to long polling when WebSockets is not available? It happens for some of my users to be behind a proxy that blocks WebSockets, so they can't connect to my application. Is such a feature available on the roadmap? Currently, I'm afraid I don't think this is something we are looking forward to, but of course, in future, we'll definitely keep a note of it and try to bring out such a feature where it can fall back to long polling. Does that answer your question? Of course, with HTTP, the long polling is possible, but I'm not really sure if it currently falls back to long polling. I'll take this question offline with you on the Slack channel. I think that would be best. Any suggestions on how to perform data access control? So if you're familiar with permissions in DeepStream, we have a permissioning language called. So I'm quickly going to show you on the website. We have a permissioning language called Valve, using which you can permission all that happens within your application, and you can completely restrict the access or allow access depending on various parameters. So you can just go through this documentation. It's pretty straightforward and it should help you. Okay. Questions about roadmap, like when will we add GraphQL support, will probably be more, will make more sense to be taken on the Slack channel. Probably this webinar is not the great place to ask. All right, do we have any other questions? Okay, then I'm gonna leave you all right here. Thank you so much for joining in. Hope you all have a good time. See you all.